All right, welcome back from lunch. I know many of you may be a little drowsy after eating the food, so I want to start out with a totally awesome and contextual joke. What did the message queue say to Flink? Dwarf for Link! Huh? Like, maybe you're thinking, that guy for that guy? Really? That's because you're thinking about it in processing time. Flink knows the real answer because it uses event time. It knows that you meant Flink forward. Huh? All right. So I'm pretty new to the world of streaming, so I want to tell you guys a little bit about me. Besides telling totally hilarious jokes, I am an engineer at Lyft. I've been there for a few years now. I started out on the ETA team. So this team calculates the driving time between 2 points as accurately as we can. You can imagine this is fairly important for a company like ours. I'm getting a big head-shaking nod from someone. We try. We're one of the most accurate in the industry at that, actually. And when I joined, I was given the task of the big data processing aspects of the ETA system. So we process a lot of data to do this. And there was actually very little automation about it when I joined. So when I built my first model, it took me 4 months. And I did a bunch of work, and we did a bunch of iterations on this, and I've gotten that down to where now it takes 10 minutes. So we're rebuilding models every 10 minutes now. We've even incorporated real-time traffic aspects to this. So now, as we see traffic conditions happening, we react to that, and we make the ETAs more accurate. Now, as part of that work, I started generalizing some of this orchestration and the big data processing, and that is a team I started we call Flight. So we use a large-scale orchestration engine to manage these many jobs that we have running concurrently, and we do a large amount of batch compute. Some of that's Spark, some of that's AWS Batch. We have a few other things custom built in there as well. That work started transitioning into something we call the data science platform when I joined that team. And as part of that team, I started working on the API we have to give to our data scientists to code up their jobs and do their experimentation and prototyping for machine learning as quickly and efficiently as they can. And when I was doing that work, I started to identify a pretty big problem in that industry, which is around how we do real-time feature generation between prototyping and production cases. And so I started another team that's called Drift, which is our real-time feature generation for machine learning. And digging into Drift a little bit, the first thing to know is not every code name at Lyft has to have a Y in it, but it is better if you do. And this team was formed around the need for consistent feature generation. And Anand touched on this in his keynote this morning of machine learning is really only as good as the data that you have for it. And subtle changes between how you calculate your features can make a big difference in the results. So in particular, between the training stage, when you're typically doing batch-style processing, you probably will use something like Hive or Spark, one of those tools. And then when you go to your online system, typically you have a different set of technologies like Storm or some stream technology, and you end up coding up your algorithm twice. And that can lead to subtle differences between the two. So what I started pushing was we needed to unify this and use only one engine to calculate our features. And so Flink is a pretty natural fit for that, right? Because we can do both batch and stream style processing. So started a project around doing the stream processing as a service, using Flink as our processing engine, and then building some automation over the top of that in order to drive these jobs, because we're looking to have thousands of features running on top of this. So you need some level of automation in order to make these jobs run, do backfill jobs, just manage everything. And so what does this have to do with bootstrapping? So many of the features have a stateful aspect to their calculation. But before we talk about what bootstrapping is, we need to have a group understanding of what we're talking about in terms of bootstrapping. So the first thing to understand is that bootstrapping is not backfilling. Backfill is the operation where you're taking historic data and you run your algorithm on that in order to get results for that historic data. And this is a typical operation when you've had an outage in your processing. or you've come up with a new type of logic or piece of business logic or algorithm, and you want to see how that would perform over the historic data. But bootstrapping is something different. So let's maybe look at an example so we can start understanding this together. So this is a simple little stateful stream program. And all I want to do here is I'm going to count the number of words that appear in a stream. And it's going to be over a 7-day window. So a 7-day window with sliding with every 1 hour. So we end up with 168 buckets for this. And, hopefully everyone's familiar enough and my pseudocode is close enough to where this kind of makes sense. But it's a job that's going to add up the number of words it sees over a 7-day period. So the thing about this, you deploy this on day 1, it's going to start producing results, but the results are wrong, man. You have to wait 7 days. And you sort of go through the 7 stages of grief in this. You start out kind of angry, why do I have to wait 7 days? And you just want it to be done, and you're finally so relieved when you get it after 7 days. So that's not a great experience to have to wait 7 days to start getting the real results out of your program. But I actually had a different problem that I ran into. One of the first features that the data scientist asked me for is the overall ride count for users. So for each user, for each passenger, how many rides have they ever taken? Right? So this means you have to count all the data in the history of Lyft, and then we still want it to be very reactive, very low latency to get that feature updated. So I have to go over all of our historic data and then join that into our live data somehow, right? And conceptually, the program is super easy. You can use streaming SQL now, just select user ID, count their number of rides they've taken. Great. We're talking about 5 lines of SQL, and yet you can't run this job. If you start the job, you'll never get the right answer, right? It will always be wrong. All you'll see is the ride count from when you started the job. So what is bootstrapping? So bootstrapping is how I'm going to try to feed historic data into the system to get the state built up, and then join that into the live stream so that I can get the correct answers for my job. So this way, you can apply this generally. It means that when you launch a job, after this initial bootstrap, you start getting results. So even on that 7-day job, we can start getting results on the first day. Great. So a couple of things to cover before we start talking about solutions. So one is about provisioning. So one of the things to realize is if you're going to do this bootstrap step, let's take, for instance, that 7-day job. If you can't bootstrap faster than 7 days, then it's kind of a waste of time. You could have just run the job. And so we want to be able to bootstrap very quickly. So that sort of suggests you want to have a high level of parallelism, throw a lot of compute resources at it, and just sort of catch up to reality or catch up to real time as fast as possible. Then, once you're caught up, you probably need less resources. Now you're just processing the live stream as it comes in, and you just have to keep up with how fast the events happen in real time. So that means you want to probably set the parallelism lower. And in the case of Lyft, we're looking to run thousands of these jobs, so it's very important that they be efficient so that we don't spend a ton of money processing all these different features. Another thing to keep in mind is that generality is pretty important. I'm going to have 1,000 different of these applications. So I kind of want one solution that kind of works across many things. There are depending on how your algorithm works, you could come up with a simple thing that works for that style of algorithm. I want something generic so I don't have to think about it for each new feature as it gets introduced. And then because I'm at Lyft and I want this to be used in production, I have a strong skew here in my solutions towards production readiness. I'm pretty risk averse, I guess is the right term to use here. And so maybe some of the things I'm doing aren't going to be the right choice for you guys. You might be more willing to take a risk or try out something new and different. So yeah, now we can talk about potential solutions. So the first thing to think about is using stream retention. So hopefully, many of you are familiar with this. If you're on Kinesis or Kafka, it provides very low latency throughput from inputs to outputs, but it can also hold a bunch of data. And so this is an important feature for when you do recovery on a fault. But you can configure the retention to be quite long if you want to. For Kinesis, it can be 7 days. For Kafka, there's no inborn limit, but you can really give it a lot of storage if you want to. It just kind of gets expensive, but still. So it's sort of within your control as to how much data you want to retain. And the great thing here is, if it is in your message bus, you can just set back to how far you need to go for your bootstrapping, and then just process it as a stream. So now with your one connector, you're like just your Kinesis connector, your Kafka connector, you just process through the data until you catch up to reality, and there's no change. It just continues on into the live data. So basically, if this is feasible for you, you should go down this path. It's really the easiest thing that I came up with. So then the next thing I thought of was, wouldn't it be great if you could have infinite retention? Then you never have to worry about anything. So maybe one way that could work is you alter Kafka to when it's going to age out a partition. Instead of just garbage collecting and throwing it away, maybe you could have a secondary storage. You copy from your primary store out to a secondary store like S3 or Glacier. And then, Kafka knows how to bridge that, bring that data back into primary store or deliver it to you directly. And so the advantage here is it's still just one connector. You can still just use that one way of getting at the data. And it's going to be a lot cheaper. And potentially you could bridge to data that was outside of Kafka to begin with. The disadvantage here is you may end up with very different performance characteristics between the primary and secondary storage. You might have to account for that in some ways. And then that provisioning aspect I mentioned before around how you might want to high provisioning when you're doing the bootstrapping versus lower provisioning once you get to the real-time stream. There's no super obvious way of identifying when that would happen and how you could re-provision on Flink. But probably the biggest disadvantage to the system is that it doesn't exist. So we'd have to go make this. And I'm not really that willing to go change Kafka for my project right now. So this didn't work for us, but it would be great. There are some things out there like Apache Pulsar and Pravega, who's here. They provide this sort of functionality. So if that ecosystem would work for you, it's definitely worth checking out if you have these sort of bootstrap style problems. So then the next thing is, let's take a step up. So going above the message bus layer up into the source layer. So the next thing we could think about doing is, why don't we write a source for Flink that knows how to look at our historic store and then transition to reading from the message bus, reading from the live data. So this is sort of an illustration of how this could work, where you have a discovery part of your source that issues a bunch of messages, first reading from S3 and then transitioning over to Kafka and pushing that over to a reader that knows how to read the data and delivering that to your business logic. And yes, all of my messages are on scrolls. It's awesome. So the cool thing here is now all of a sudden we're divorced from a technology underneath us. We could use any sort of underlying secondary store, any of the message process. So S3, or maybe you're on Google infrastructure, maybe you had your own infrastructure, and then you could use Kafka, Kinesis, whatever it is. You're basically in control now, so you can bridge between those things. So it's potentially a very generic solution. The disadvantage here is that writing sources is pretty hard to make right. Getting your watermarking correct, getting the order of the data in a way where you get efficient processing out of your business logic is no particularly straightforward way of making that happen. And then again, that provisioning step I mentioned around high to low as you go from the bootstrapping to the steady state, again, there's no particularly easy way of signaling that in the system that you can do that operation. So I went one more level up in the stack, up into the application level. So still trying to make something generic, but now we're talking about writing it in Flink's programming model. And what my idea is, all right, I'm going to write two programs. One's going to be a bootstrap program. It's going to read the historic data. It's going to process all of that, and then I'm going to take a save point. Then I'm going to run a second program that starts from that save point, but this time reading from Kinesis, and then continues to run the same business logic forward. So the advantage of that is I don't have to modify any of the stream sources. There's no modifications to Kafka or Kinesis or any of that stuff. There's no modifications to a source. I'm using sources that other people have written and vetted already, so I feel good about those. Plus, now I've got a solution where I can bridge between that high provision state and the low provision state. There's a very natural break between the two programs, so I can make a decision about the relative provisioning for these two jobs. And let's find out what the disadvantages of this were. So here's a little illustration of kind of where I started out with these programs. So just two jobs, S3 source, my business logic, syncing out to, this is really just logging at this point, and then save point, Kinesis on the second job, read from Kinesis, same business logic, and then syncing out, and we have a production store at Lyft where that syncs out to. But because I'm bridging between these two data sources, it's very important that I not repeat any of the data. So, okay, no problem. I've added some awesome Lyft Pink here stuff, which says, okay, when we're reading from the secondary store, we'll just filter and say, as long as it's below this target time, we'll process that. And then we get up through that target time, and everything above that that happens to be in our secondary store will be filtered out. And then we transition to the live program. And here we just have the opposite condition. So we can process through all of our the retained data in our store, and then we won't start including it until we're at least at that target time. So that way we have no duplicate data. But now, that save point thing, how do we trigger the save point? So this part, again, I've got some crazy Lyft Pink stuff here of what's changed. What I did is I had to change how the source works a little bit so that when it gets through all of the data that I care about in the secondary store, it sends a signal through the stream at the end. And I actually used the watermark to do this. And that still processes through the same filter, same business logic, syncing out. And I have a thing at the end, a termination detector, that looks for when the watermark goes beyond the time I've chosen as my signal. And at that point, it knows, oh, hey, I can now trigger the save point and cancel this job. And I have some external automation that watches for that job to end and says, oh, great, it's over. Now let's go start up the Kinesis job. So, what did I learn when I did all this? So I found out that you can automate Flink from within Flink. It's possible. I spent many hours cursing at my computer as I tried to figure out why it wasn't automating correctly. So it's pretty fragile. So you can make this work, but you're probably going to end up spending time debugging very subtle aspects of how Flink works. And the other thing that I ran into is that the save point logic is all via the UIDs, right? Probably many of you who've been using save points know this. And I wanted to have most of my features be stated in SQL. There's no way to set the UID on your operator in SQL currently. So this ended up being the reason why this didn't end up working for me. So I went to a second application level attempt. This one's a little bit different. We still have two jobs, still have the high provision job and the low provision job. So that's nice. That fits one of my requirements. But in this case, I actually read from both sources simultaneously. So I'm going to read from S3, and I'm going to read from Kinesis. I'm going to union those two together after the filter so I don't get duplicate data, process that through the same business logic, and then push that out to my sink. And then at a time of my own choosing, once the bootstrap's done, I can trigger a save point and cancel the job. I can replace that with a job with the exact same shape, but now restoring it from the save point, but with lower provisioning. So to give you a visual of how that job works, it's just sort of same as the previous one, the two sources, the two filters, but now those get unioned into the business logic, and we push it out to the sink. So this is great because it's way less fragile. There's no crazy signaling using watermarks going on, and this works great with SQL because the job has the exact same shape, and therefore, as you restore it from the save point, it works even with the lack of UIDs on the operators. The disadvantages of this is you have to have some sort of external automation to this system. Something has to monitor when you've reached past the save point and say, oh, okay, you want to go to the lower provision job? I'll trigger that save point for you. You could just go with the high provision job all the time if that works for your scenario. But for what I'm trying to do, I want to get to that low provision job. So it's very important that I have some external automation. But I was going to build the automation anyway, so that's not a big deal for me. The other thing to consider about this is that because the S3 data is probably much older, in our case, like years old, while this program starts running because of how the windows and the counting, you're just going to buffer up all of the kinesis data that's coming in. So you're going to buffer that in your Flink state until it finally catches up to reality. And then that's when you'll actually start processing the kinesis data. So depending on the relative volume of your historic data to your current data, the streaming data, that may prove a limitation you can't get around. So it's just something to consider. And you may ask, like, is this more than just diagrams? Like, yes. Here's that same program in the operators that I had running in production at Lyft yesterday. And so this gives us our live ride counts. It's totally awesome. And we're actively trying to add more features to this now. So it's an actual working thing, not just a prototype now. But it doesn't really feel done. I think there's a lot of ways we can make this better. So first is that Kafka infinite retention idea that I mentioned before. I think it's a really cool idea. It's one of the things to also consider there is that you may want data partitioned differently between when you're doing that historic backfill bootstrapping style operation and when you're doing the live processing. So being able to repartition the data is also an important thing. Again, this is another thing that Pravega can do for you. Another path could be programs as sources. So as I mentioned, sources are complicated to write and get them correct. And that's because you have to go to this lower level programming model outside of the normal Flink metaphor of programming. But if I want a source that's really just the union of a couple of other sources, it'd be great if I could say a source using those Flink primitives. So Beam actually has started down this path with something called the splittable doFn. It'd be an interesting path to sort of explore if we could come up with a source that's like where you can combine those two things in a way that's you can be pretty confident will be correct the first time around. Another thing is that I have to do this operation where I say, okay, here's the high provision job, and then cancel and replace that with a low provision job. It would be more awesome if I didn't have to cancel the job. But I could just say like, oh, okay, cool. Hey, Flink, I don't need this level of parallelism anymore. Could we just go lower? And this is a feature that's, I think, coming in Flink 1.5.6, something. So, sometime soon, there's we're going to be able to reprovision. Okay, 2.5 apparently. But someday we'll have this in Flink, and that will make things a little bit easier. Another thing that I ran into is that when you're doing the bootstrapping aspect, you probably don't care about checkpointing nearly as often as once you get to the live things and once you actually start serving these values in production. So being able to change the checkpointing policy between those two stages would also be a very useful operation. And then another thing is, I mentioned that I use the watermark as a signal that goes through the stream. What would be great is if I didn't have to overload this concept of what a watermark is in order to make this work. It'd be great if I could just define my own metadata, my own meta message that I can pass through. It's not real data, right? It's not processed by your process function. It's a meta message that I can use to signal other operators down the stream. They can say, oh, cool, everything's been processed. Here's this message that says terminate. I'll do that now. Right? That's probably a less error-prone way of doing that first style of application level scenario that I mentioned. And then some of you may be thinking like, everything he talked about is using the streaming engine. Why didn't he use the batch engine at all? And that's a good question, because the batch mode processing can be a lot more efficient than streaming processing, because typically your offline data is stored in a way that's already more efficient for batch style processing instead of stream processing. Sorry. And you can do some different things algorithmically if you know all the data. You have a priori knowledge on the sort of the time span of the data and where the data is all going to be. And there's a couple of ways you could think about using batch mode in a bootstrapping operation. So the first one would be use batch mode to process the historic data and then make a save point be one of the outputs of your batch job. So this is cool. It's potentially very generic. You have to understand the save point file format, which I don't. Maybe some of you guys do. So I was scared of that one. I didn't want to really go down that path. But once you write out that save point, on the other side of it's pretty easy, right? And you just start a streaming job from that save point data, and then everything's great. So that's a potential thing that we may see in the future from Flink and data artisans. The other method would be maybe a little bit deeper integration into how Flink works, which is just tell Flink like, hey man, I've got all this data. This part of it's historic. This is where the stream for where you can get the real-time data. Bootstrap this. And it would say, okay, cool. I'll start out in batch mode because all that data is in a batch-friendly format. And I'll use my batch way of processing things to bootstrap as fast as I can. And then once it reaches that timestamp where the transition is between the historic data and the real-time data, it would automatically understand, hey, let's move over into our streaming algorithms, our streaming way of processing this algorithm, and sort of continue on from there. And that way there's only one program doing it. There's no need for a save point. There's no transition time at all. But that's obviously a pretty deep and hard thing to do within Flink, and certainly beyond my skill level. So, sort of concluding, what did we all learn here about bootstrapping? So many stream programs are stateful. It's certainly possible to do real-time bootstrapping faster than real-time bootstrapping. So it's better to do this than to wait 7 days. But there's still many ways we could possibly improve this. So I think we should all sort of as a community be investing in this area and trying to make it better. And that's my talk. We have questions. That's at least a few.
Hi. You mentioned about the watermark pushing in the processing time. Mm-hmm. Have you considered pushing that into the sink and somehow the servicing layer figure it out what to serve based on the source availability?
Right. So one of the sort of subtle aspects of how this works is you want to make sure all the data makes it all the way through your system, right? And it's a distributed system. You kind of have to understand the state of all the different operators. So that's what makes watermark pretty convenient, because the high watermark will only get advanced once all of the operators have reached that point. If you start going outside of the Flink metaphor with another type of signal, you have to come up with your own way of synchronizing across the operators and making sure all of them have processed the data.
You mentioned that in your high provision path, you take a save point at the end of it, and then in the low provision, you restore from that save point. But the source and these two are separate, right? One is S3 and another is Kinesis. How does your low provision path knows where to start from? Because it can start from earliest or it can start from latest, right?
Yeah, the way I handle that is those time filters. So you just process everything you have historically. I use an application level time filter to where none of that data past a given timestamp would be included in what's in the save point data. And then when I'm reading from the stream, I go back to the full retention. Just start like trim horizon, go back as far as I have, and you start processing forward with a filter saying if it's less than a given timestamp, just throw it away. Right? So just wait for the data to reach that same timestamp that I had for S3, and now this time we just include the stuff on the other side of it. So yeah, it's not very intelligent, but it works.
So this sounds actually surprisingly similar to a process that we've gone through probably half dozen times in the last couple of months. We always have the same problem. You kind of glazed over it a little bit. I'm curious if you can give some more details. You mentioned that you have two streams. You're replaying the older stream of historical data, and that you're going to go to the low provision job once that completes. And the problem that we've always had is trying to detect in some sort of mechanical, automated way when that actually occurs. So you're reading from S3. Is it easier from S3? From Kafka, we basically, our only option that we've seen is trying to look at like Zookeeper commit offsets. Is there some other way that you have through Flink to be able to know when it's done?
Yeah, what I did, there's a little part I kind of glazed over here. You can kind of see it in this job. I'm just looking at watermarks, right? So I just wait for the watermark. It's probably pretty hard for you to see in the back. I have this crazy watermark format. This is something I came up with for my own debugging reasons. But what this is it's a long that's a human readable date. So you probably can't see it, but it's 18 because it's 2018, 04, 09 because it was April 9th. So it's pretty easy for me to like just look at the watermark of the last operator there and understand like I've gone beyond when the program started. So now I know that all of the S3 data has been read and fully consumed. And so now I can transition the program into the lower provision state because now there's no more S3 data to be read.
So you're still doing that basically through like human intervention. You're looking at the digraph and switching it over?
That's right.
I imagine we could probably get Flink to figure that out too if it's just looking at watermarks. Might be.
Yes. So potentially a way of automating this would be to end up triggering a side output at some point and then having that feedback into Flink and reprovision the job once Flink supports being able to reprovision in that way.
Okay, awesome. Thank you.
Any more?
Hi. How do you reconcile the two different syncs coming from the backfilling job and the live job? Like, do you write two separate syncs? Is there a post-processing job that reconciles the data? How do they get combined?
Right. So you're talking about in this one where I've got the two different syncs between. So I don't actually really sync anything out in the S3 one. Really all I'm doing in that S3 job is trying to do the bootstrapping. So that really ends up writing nowhere. All I'm doing is creating the internal Flink state there. And so while I am technically syncing, it's all just logging. It's just for me to be able to see progress. So then really we don't start producing any real sync results, any real production or readable data until you transition to the Kinesis job.
Can you give us like a ballpark of what the state of the size of the state you're dealing with?
Sorry, I can.
A ballpark of the state size you're dealing with?
The state size? I've got a few gigabytes of state in this. Yeah, does that answer your question? Like, okay.
Any more
If
questions?
you listen to the Netflix talk, it's not an impressive amount of state compared to what those guys do. Oh, lots of questions. Wait, one more question.
How do you stall the live stream while you wait for the other stream?
I can't.
How do you go about stalling the live stream while you wait for the historic stream to? Is it just,
Flink is going to just buffer the data on your behalf, so I didn't have to do anything special there. It just based on the way that the windows work in your algorithm, it's just going to start buffering those windows, and yeah. All right. Now I think we're done.
So let's thank the speaker.
Yeah.